All right. So any questions about what we covered in this initial moderation stuff last time? We talked about, we finished up talking about centering. Jack, can you tell me why we might want to go through and center our data or why it might be beneficial?
To have like the mean of zero, so then you can compare how far away, like if something's one, then it's one away from zero.
Yeah. So having that 0 point be something meaningful in our data can start to be really, really helpful. Again, write this down, like as you're working through moderation or any type of advanced regression model, knowing what zero means for each one of your variables is critical, okay? Especially as we start to go through and tease out some of this simple slope stuff. Jayla, you had some of this stuff before. Was this something that you had done previously in terms of like working with centered models or things along those lines in your previous class?
Yeah, centering we did.
Okay. So, concept is your centered variables don't change anything in your regression model outside of your intercept. Catherine, what does your intercept represent?
And all the predictors are at zero, like what your expected value of y would be.
Perfect, right? And so this makes sense. If I go through and mean center all of my predictors, right? What this intercept means is now my expected outcome of whatever I'm measuring when everything is held constant at zero. In my uncentered solution, this is the expected value of functioning for people with no pain, not using opiates, with zero scores on PTSD, right? Versus here in my centered solution, this is my expected value of functioning for people at average levels of pain, at average levels of PTSD, controlling for opiate use. We're seeing much lower expected values relative to this. Again, like I cannot stress enough with these models to think very carefully, like what is this literally saying, right? That will really help you start to get a handle on kind of what's going on with this. Okay. So does the centering change our skew or kurtosis, shape of the distribution, anything along those lines? Nope. It's just a straight up switch so that zero ends up representing the mean of the mean of your variable. Okay. And what we'll do when we start to move forward with this, we'll start moving that 0 point around to start testing specific things that are of interest to us. Okay. So we've got centering, so this is good. We've plugged this back into our regression model. See, it doesn't do much, okay? But going back, remember that what we're trying to do in this moderation is we want to look at the change in an association between variables at different levels of my moderator, okay? So maybe my question here, what's the relation of opiate use on role functioning at different levels of pain and PTSD, okay? If we just set up our straight additive model here, right? Here's my intercept, here's my coefficient for pain, here's my coefficient for centered opiate use, here's my coefficient for centered PTSD, okay? As Catherine said, this is the expected value of functioning for at average levels of pain, at average levels of PTSD, controlling for opiate use, okay? What it's saying here is that per unit increase in pain, I see a 10 point, close to 11 point reduction in functioning. For every unit change in PTSD, I would expect a corresponding about a quarter of a point decrease in functioning. Charlotte, do you remember why? Boy, that looks like a whole lot more than this, right? Can we make strong interpretations with these unstandardized effects or with these unstandardized coefficients? Why not?
Because it doesn't really mean anything on the scale of the model as a whole. It only means something relative to the actual measure.
Yeah. This is a 1 to 6 scale. This is like a 1 to 120 something scale. A 1 unit change in PTSD on our PTSD scale is a far finer change than this, right? So again, this is where some of our standardized coefficients start to come into play. Sort of getting within a model, starting to see which one of those is sort of carrying more weight with stuff. Okay, so let's go through then, if our question is, how does the relation of opiate use change with respect to role functioning at different levels of pain and PTSD? So let's go through and do some math. Okay, we're just going to do some basic algebra and start plugging values in. Okay, so my reference values, and this is another nice thing, if I go through and center variables, if I want to look at a standard deviation above or below at a variable, for pain, it's just a standard deviation above and below. 1.34 is a standard deviation of what above, negative 1.34 standard deviation below, right? Same thing for high and low PTSD. Standard deviation is 19.76, so it's just 19.76 negative 19.76 takes a standard deviation above and below. Opiate use, circle this and mark this. Standard deviation above and below for opiate use is 0.5 and negative 0.5. Is it always going to be this way for dichotomous indicators? No. Why does it turn out to be this in this sample, William?
Because you have like equal numbers.
Yeah, I've got a balance set, like almost perfectly balanced. Don't just start plugging in 0.5 and negative 0.5 for dichotomous values, or you'd be off unless you're sort of dead center and even on this stuff. Okay. But so we'll go through and say, what I want to do is I want to look at the relation between opiate use and functioning at high pain and high PTSD. So people who have high levels of pain, high levels of PTSD. So what I can do from my data, I can say, well, high pain corresponds to value 1.34 and high PTSD 19.76. So let's just plug those into my model and see what happens, right? So I go through and plug in my value of pain, my value of PTSD, go through and run this out. And I get predicted value is going to be 29.3 minus 0.69 for opiate use for individuals at high levels of pain and high levels of PTSD. All right. Well, what about then if I want to go through? And so if I were to go through and I were to spin this out, so put this in for people who have are using opiates and who aren't, I get for no opiate use an expected value of 29.65 for people who are using opiates, an expected value of 28.96. We'll see where I got those from. We're just putting in sort of in my data set what corresponds to a value of negative 0.5 is no opiates, value of 0.5 is opiate use. So just dropping that in there. William, what's the difference between those two numbers exactly?
Like 0.67.
What's that?
0.67.
Almost 0.69, right? Remember, thinking about just sort of building off our conversation, right? If we have a coefficient for a dichotomous indicator, that's just telling us the expected value between groups after we go through and account for other variables in the model. Okay. So, all right, we're expecting about close to 3/4 of a point difference in functioning across people who are using opiates or not, right? When we're holding at high levels of pain and high levels of PTSD. Okay. People see how we just kind of plug this math in and got the values we're looking at. Okay. All right. Well, what about if we go through and we want to look at people with low pain and high PTSD? So here's my model again. But now I'm going to just plug in values for low pain and high PTSD. I go through, calculate that out. What's the relation between opiate use and PTSD or opiate use and functioning? It's still the same thing as it was here. It's still the same thing as it was here. And we can go through and we can spin this out and we can see that here's the expected value for at low pain and high PTSD for people using no opiates and people using opiates. William, what's the difference between those two numbers?
0.69.
0.69. It's still the same thing, right? So it doesn't matter, right? So let's go through and sort of change things around. What if we want to look at the difference in what's the relation of PTSD at different levels of pain and opiate use, okay? So again, we've got our model. I go low pain and opiate use. So I go through and plug in values for people who are using opiates, low levels of pain. Here's the effect I get. My coefficient for PTSD is negative 0.23. It's the same thing it was in my base model, okay? And I can go through and say high pain and no opiate use, plug different values in. I'm still getting the same association. Okay? So within this model, Catherine, does it matter what I plug in to these other variables? Does that ever change the nature of the relationship between one variable and my outcome relative to my full model? It doesn't, right? And what happens in my standard additive model, the effective x on y, so my individual coefficients are going to be the same across all other levels of predictors, right? So the effective x on y is going to be constant. In this model, the effective x on y is going to be constant for all levels of my sort of other variables, okay? So this is when we're going through and we're interpreting our standard additive regression models, okay? We're saying that this is the unique effect of x on y holding all other variables constant at 0, which is true, okay? But does it really matter what we're holding all of the constant variables constant at? No, I mean, because these, so I can throw whatever values in I want, and it doesn't change the slope of these, okay? It changes my intercept because that's my expected value, right? But it doesn't change anything else, okay? And this is what happens. If we go through and we take a look at, for example, here, the relation between, what do we got here? PTSD and functioning for people with low pain and opiate use, high pain and opiate use. We're seeing a shift in kind of our line here. And so this is a change in our intercept, but these slopes are parallel to one another. Nothing changes, okay? So is this useful for asking moderation questions? No, it's not, because it doesn't matter what I change. If I say opiate use is my moderator, I can throw whatever values in there. It never changes the relation, right? I'm just not getting at what I'm trying to get at, right? I can't test moderation with this additive model. I can't sort of change around where my 0 point is or things along those lines. It doesn't do anything, okay? If you will see mathematically why we're kind of running into a wall if we're wanting to ask moderation questions with a standard additive regression. Okay. So what we need to do if we're wanting to test moderation questions is we have to go through and start to include some interaction terms, okay? So let's say we've got 2 questions. We want to know whether or not opiate medications impact the relation of physical pain on role functioning in survivors of serious accidents. And does pain severity change the nature of the relation between PTSD and role functioning accident survivors? Okay. Do this, your life is going to be a lot easier, okay? In this first question, okay, opiate use influencing the impact of physical pain on role functioning. Cindy, what is my kind of base relation I'm looking at here in this first question? What's my main predictor that I'm interested in for question 1?
Opioid use and role function.
Okay, so we're talking about that your opiates influence the relation of physical pain and role functioning. What's my base relation that I'm interested in here?
What do you mean by base relation?
What's that?
What do you mean by base relation?
What's the if I'm saying here x and y, what is my x and what is my y from point 1?
Opioid medications.
Okay, so I've got opiate medications is the thing that's influencing. What's my x here of interest conceptually? Physical pain, right? So I've got pain on functioning, and then Cindy, what's my moderator?
No.
Opiate use here. Okay. Say drugs. Right. Does opiate use change the nature of this relation? Okay. Jayla, for that second one, what's my base relation here that I'm interested in? Yeah.
And
PTSD and functioning. And what's my moderator in this one?
it's very.
Pain. Right. Okay. Anytime you're looking at one of these moderation questions to draw this out, Okay, it's gonna be really, really, really helpful. You need to know what is, and we're gonna call this here, this is gonna be your conditional effect. Okay, this is gonna be the effect that changes depending on level of your moderator. Okay, so want to be very clear when we're going through and tackling these. You want to be super clear. What is my conditional effect? What is the moderator? Because that's going to impact how you go through and probe and test this. Okay. Now, Catherine, could I go through? Could I test this in this same model? Yeah, right. The interaction's interchangeable, right? It doesn't matter, right? This is completely conceptually up to you how you want to go through and tease this, right? But generally what you'll have with these, just like when we're working with our factorial ANOVAs, there's generally kind of a conceptual thing that you're thinking about. Like here is, and it's often, here's the thing that's known, right? X and Y are related over and over and over again, right? If I write a paper that says X and Y are related, no one's going to be excited about that, right? So that's often going to be your conditional effect. Your moderator is going to be the thing that you think is going to change either the magnitude or direction of that association, okay? So just wanted to go through, and this is going to start to become important as you're going through and factoring things out. Now, which of these is going to be your conditional effect, and which one of these is going to be your moderator? You'll kind of see what we're getting at with this. Okay, so there's a big conceptual difference in sort of how you're going to go through and tackle this stuff. Okay. So in order to test these, right, what I'm going to do is I'm going to set up a multiplicative model here. So I've got pain, opiate use, and PTSD. And then I've got two interaction terms that are specifically I'm including to test these hypotheses. Okay. I've got opiate use and pain, which is getting at this. And I've got an interaction of pain and PTSD, which is getting at this. What don't I have in this model? Think about like maybe your ANOVA designs. Yeah, sure.
Just like opioid and PTSD.
Yeah, so I didn't specify an opiate use and PTSD interaction. What else don't I have in here? Yeah, a three-way. I don't have a three-way interaction, right? Opiate use, pain, and PTSD. Could I put those in there if I wanted to? Certainly. Do I have to? Nope. Right. And again, what happens here? When I'm going through with my standard additive regression, if I start throwing variables into the mix, what I'll see is, there's individual coefficients start to change because we've got shared variance and things like that, right? But you want to be careful when you're thinking about interactive terms, because as soon as I start throwing interactive terms, now all of a sudden those coefficients start to be dependent on other levels of things, right? Now, if there are interactions in there, interactive effects, that's a fine thing. But your model can also get, like, if you were to go through, let's say you have 4 predictors, your models can start to get really, really, really big, and your power to test, particularly even 2-way interactions, much less 3-way interactions, starts to get really, really tight. You're just adding complexity into your model, right? So you want to think carefully about what interaction terms do I include in my model, what are important, and if you can't imagine what an interaction might look like because it doesn't make a ton of theoretical sense, it probably doesn't need to be in there, because even if it popped up, then you have to go through and explain it. You look kind of like a doofus trying to like just make stuff up, right, for why this is a real thing as opposed to some random artifact of your sample. Okay, so you just want to think carefully about how to go through. Now, if opiate use and PTSD do interact in this, then I've technically got a model misspecification, because that should be in there, right? But for me, I'm thinking opiate use and pain, those two things go together, and pain and PTSD go together. Opiate use and PTSD, I'm having a hard time thinking about like why that would. I mean, I can imagine a reason and make one up, but it's probably going to take an argument right? And so want to be thinking carefully about how you're going through building models. Did you have a question?
Oh, yeah, I guess like, when you're thinking like, from a theoretical perspective, like. Like two variables being correlated isn't really a strong rationale for an interaction term.
No, not at all, right? Because remember that interaction is independent of one another, right? Like I don't have to have a base effect with my outcome in order for this thing to be involved in interaction. We're going to see this with OBUs. Did OBUs pop up as in our additive or simultaneous regression as an important construct? No, it's functionally, there's no evidence that it has anything to do with in a direct effect on your outcome, right? So you might say, oh, well, this is an important variable, we don't need to worry about it. Like, well, maybe not, right? It depends on how that's going through and playing in. Yeah.
So then once you see that it's not like important, then that's when you decide to like, oh, let me try it. Right.
This is all conceptual, right? So like, this is your question, right? You're saying, what I'm saying is, I think I have reason to believe that the relation between pain and functioning may depend on whether or not people are using medications, right? And I can make an argument for that pretty straightforward, right? Well, if I'm on medications, then yeah, maybe that starts to decrease. If I'm not on medications, as my pain goes up, my functioning is going to go down. If I got good pain medication, right, that's useful, maybe this relationship starts to decrease, right? Here, PTSD is related to functioning, certainly, but maybe, boy, if I start throwing pain on there, in addition to PTSD, maybe that starts to get stronger and stronger and stronger, right? I can come up with a pretty straightforward reason for why this. And then that's a pretty good indicator why you might want to go through and start modeling things. If you can't articulate why those things, why something might change the nature of the relationship with something else, you kind of got it. I mean, like you could find something, although these are tough effects to find, but you're going to be stuck holding the bag trying to explain what's going on. And if you can't do that, it's kind of a tight spot to be in. So this starts to become much more in terms of thinking about like, how do I go through in the introduction of a thesis or a paper? How do I present why I'm doing this in the first place versus here's just a random collection of variables I threw in a pot and I'm seeing what's falling out. Okay. So here I've got my opiate by pain interaction. This is testing the hypothesis that the relation of pain and functioning depends on opiate use. Pain by PTSD interaction. This is a test of the hypothesis that the impact of pain on functioning depends on level of pain, or PTSD on functioning depends on level of pain severity. Now I could flip-flop this around. This could be equally a test of whether or not the relation of opiate use and functioning depends on level of pain. Mathematically, I can test that, but that's a weirder thing to try and talk about than the other way, right? Does the impact of pain on functioning depend on PTSD? That could be, I could maybe make an argument for that. But so this starts to become that you thinking about like, which is the stronger argument. And sometimes it will be driven by what's going on in your model. Okay. It's easier if I find here an effect of PTSD on functioning at average levels of pain and then sort of going through and thinking about how that works. If I flip this around and find that pain doesn't have a relation with PTSD with functioning, regardless of what level of PTSD it is, then that can be a difficult thing to talk about. Then you kind of got to flip flop it. Lucas and I just published a paper where I had to kind of pull a little bit of a fast one where we switched our moderator and our conditional effect around because in the one way it changed it, but like it was the conditional effect was never associated with the outcome, right? So it just depends on kind of where you're at and sort of looking at things. Yeah.
So then in that paper, you talk about that like throughout?
Yeah.
Like-
Well, you're just talking about, and should I say pull a fast one? I would have caught that and wanted them to say more about that, but like I sort of we kind of flew that one under the radar a little bit. But when you're looking at experiential avoidance as a moderator versus experiential avoidance as the conditional effect. So in one thing, and there was some nonlinearity, some nonlinear effects, and there was a cool paper. But in one of them, sort of in one analysis, one outcome, modeling experiential avoidance as kind of the moderator. And then in a separate on a different quadratic effect, it was the main driver. So still talked about it in ways that made sense, but was one of those things I was mindful because recognizing there was an inconsistency across things. The reviewers didn't seem to mind, so I guess we must have done a good enough job of accounting for it, but these are mathematically interchangeable, so you have to make sure that you're thinking carefully about how you want to go through and talk about things. Okay, so again, interaction effects are mathematically symmetrical, right? You can flip-flop this back and forth. And so again, when you're looking at your problem sets, making sure that I am giving you how I want you to go through and look at it. So make sure that you're probing it that way. All right. We can go through and talk about how we go through and start to pull these equations apart. I've gone through, one thing I did, I don't know if you noticed this a bit fooling around with stuff. Trying to figure out like what handouts I've got in the wild courses. I went through and numbered these to try and help sort of give you, because otherwise it's just a bunch of random things and it's hard to figure out what goes where. I went through and numbered these, so you should be able to see things that are going within things. There's a handout of me walking step by step. If your algebra is rusty, you're having sort of have to sort of jump back into like, how do we actually do this? I'm going to walk through it here, but what we're going to go through and do is sort of in that worksheet is just a step by step. If there are lots of different ways to do this, but if you follow those instructions, you will arrive at the right answer. Okay, you're going to want to know how to go through and reconstruct these equations in order to get your simple slopes. Okay, so we're going to walk through this now, but also there's a handout in wild courses. Make sure you get that. Make sure you take a look at that because you want to make sure that you're solid on this. Okay, but for the first time out, let's go through and take a reduced version of our full model here. Okay, what we're going to look at is we're going to say, let's say we're only interested in looking at the relation of opiate use in pain and the interaction on functioning. So we're just going to go through and look at this piece of things. Okay. So here is our model. Where did we get this model, Cindy? This model here. How did we get that? We just ran a regression model, right? Just ran our regression, pulled in our coefficients here, right? So here's our model based on our statistical output. What we can do is we can start to make this conditional effect of pain on functioning more apparent. And we're going to say that, yes, we did in fact find an interaction. So that this coefficient here is viable for interpretation. We're saying that we have a significant interaction effect in these data. Okay. What we want to do now is start to reconstruct this equation so we can start to see how this conditional effect works. Okay. So first thing we're going to do is we're going to pull down anything that doesn't involve my conditional effect. Okay. William, what is my conditional effect in this sort of model? Pain. Okay. So what I'm going to do is I'm going to go up and I'm going to look at in my equation anything that doesn't have a pain term in it. I'm going to pull this down. Okay. So I've got my intercept. I've got opiate use. Okay. Then what I'm going to do is I'm going to bracket off my conditional effect. Here's pain. Okay. And then what I'm going to do is I'm going to drop in terms that have pain as a component to this. Okay. So here I've got negative 10.05. So I'm going to drop that down. And because pain is the only thing that's attached to that, that goes out here. And then I got plus 0.460 opiate use times pain. Pull that out, factor out the pain piece. And we just got 0.46 times opiate use. People see how I got that? All right. And so this now is my model. And I start to go through and throw in different values for opiate use in pain, right? High and low pain. Generally, we talk about this in psychological research as a standard deviation above and below. Does it have to be a standard deviation? do whatever I want, right? Now, if I want to say like, oh, I'm gonna look at this relation at 4 standard deviations above and below the mean, does that make sense? Why not, William?
I'll just look at a standard deviation.
Yeah, I mean, like who's 4 standard deviate? Like, am I really interested in people 4 standard deviations? How about 10 standard deviations, right? Like, as you do that, things will get increasingly large, but you're talking about people who don't exist in the universe or only very rarely, right? So a standard deviation above, we're generally sort of using this as a benchmark for people who are still sort of in reasonable areas of the curve, but aren't like so far out that to become, like, I don't actually have data to represent these folks, okay? So if I'm looking at people who are not using opiates, okay, what I'm gonna do is I'm gonna take my equation and I'm just gonna plug in my value for people who aren't using opiates. Okay, so I've got negative 0.5 here, negative 0.5 plugged into here. And what I get in my simple slopes equation is and then I run this out, right, add this up. I get a value or equation 10.47 minus 12.35 for whatever level of pain I have in there. See how I got that? So here is my conditional effect of pain for people who aren't using opiates. This equation says for people who aren't using opiates, I would expect per unit increase of pain, I would expect about a 12-point reduction in functioning for people who aren't using medications. Then what I'm going to do is I'm going to go through and do the same thing, except I'm going to plug in values for people who are using opiates. So again, here's my main equation. So going through, but now instead of negative 0.5, I'm plugging in 0.5. Again, please, this isn't dichotomous. Like, I won't always be negative 0.5, positive 0.5. Like, don't do that. This is just happens to be what it is in these data. But if I go through and I do that, run this out, what happened, Jack, to the relation of pain with outcome, depending on whether or not I'm looking at people who are using opiates or not?
It's gone down.
It's changed, right? It was, so now I've got a coefficient of negative 7.75, right? So depending with this multiplicative model, we couldn't do that with the additive model. We could plop in people who are using opiates or not using opiates. The effect of pain on my outcome didn't change, right? But as soon as I go through and I include this interaction term in there, now all of a sudden it does matter. If you're asking what's the relation between the unique or what is the effect of pain on functioning, I say, I don't know, you got to tell me whether or not people are using opiates or not, because it's going to change it. And now what we're seeing here is that for people who are using opiates, we would expect only a 7.75 unit decrease in functioning per unit increase in pain. So Charlotte, what happened to the strength of the effect of pain when we're looking at people who are not using opiates versus who are using opiates?
Folks who are using opiates, the strength of the effect of pain goes down.
In fact, it's weaker, right? It's not as strong. Now, we don't know. I mean, these are unstandardized effects, but this is a smaller number than this one. Did the direction change?
Yeah.
No, the direction doesn't change. It looks like as pain increases, functioning decreases. It just looks like that rate of change is weaker for people who are using opiate medications relative to those who are not. So if I'm slinging opiates, then this is pretty good, right? Then I'm like, hey, look at that, right? I have an effective medication, right? People see how we went through and so these are going to be, this represents the simple slope for pain and functioning for people not using opiates, simple slope for pain and functioning on people who are using opiates. People see how we got this? Questions on the math or anything that we've done here? Okay. So let's go through and change this around. Okay, let's go through and look at our full model. Now this is going to start to become a little bit more complex because now we have multiple interactions in our model. Okay. If I go through and I look at the regression of all of my predictors, here's what I get. Intercept, unique effect of opiate use, or actually, anytime I've got an interaction term in here, it's not the unique effect of opiate use, it's a conditional effect. Okay. Catherine, this is the conditional effect of opiate use on functioning when? What's that? Yeah, and accounting for other variables, when other variables are held constant at what?
There. At zero, the mean.
Yes, perfect. You got it all at zero at the mean. So now all of a sudden, this is a unique effect of opiate use on functioning when pain and PTSD are held constant at zero, okay? Because opiate use is involved in an interaction term. Doesn't matter what level of PTSD I hold, where I hold PTSD at in this model. If I change PTSD around, is it going to change this coefficient? No. If I start changing pain, will it change that coefficient? Yeah, it will, because I've got pain is tied to opiate use in here. Okay, and this is what will happen, and you need to be able to understand. So this, when you're going through and looking at your models to make sure that you've done things correctly. If I start recentering pain and moving that around, this coefficient for opiate use is going to change. If I go through and start shifting PTSD around, this isn't going to change. It's going to stay the same. Like, this is just incredibly important to be able to know what your model should be doing. Because you're like, this is going to be a frustrating set because you're going to screw it up. I still screw this up just because there's a lot of moving pieces and parts. What you need to be able to do is diagnose and say, that wasn't doing what it was supposed to be doing. Let me go back through and fix this. And this starts to get critical in multi-level modeling and like all these higher order general linear model stuff. Need to know how these models should be changing if we start changing around our 0 points. Okay. So here's our conditional effect of opiate use. Conditional effect of pain. This is unique. This is the conditional effect of pain on functioning for holding. We centered this. We didn't center this. We centered this. At average levels of PTSD controlling for opiate use. This is the expected change in functioning given a unit change in PTSD, controlling for opiate use and holding pain constant at the mean at 0, right? And then here are our interaction terms. So because each one of these are all included in some interaction, all of these are conditional effects. Okay. So here are our models. Here's what we're hypothesizing. We're expecting the relation between PTSD and functioning changes as a function of pain, and the effect of pain on functioning changes a function of drug use. Yeah.
Sorry, really quick going back. So the only reason that if you changed like pain, it automatically changes opioid because you have those interaction effects or terms in there, but if you didn't have them in there.
If I didn't have that in there, right? So this is the thing. Opiate use, this coefficient will change if I start recentering where 0 is for pain. But if I start recentering where PTSD is, that's going to stay the same. Because PTSD can't impact this because opiate use isn't tied to pain in anything, right?
Gotcha.
But pain and PTSD is going to change, or sort of pain is going to change if I change opiate use. Pain is going to change if I change PTSD. PTSD is going to change if I start recentering pain, but it's not going to change based on opiate use because it's not tied together.
Okay, gotcha. Thank you.
Yeah. And so this is the thing. Generally, when we're going to be looking at simple slopes, it's when I find evidence, like I have evidence of a significant interaction of opiate use and pain, significant interaction of opiate use PTSD. But even if those aren't interpretable like P less than 0.05 effects in the model, these coefficients are still going to change.
Sorry.
Yeah.
What do you mean by pain and opiate use is not tied together?
So pain and opiate use is tied together. PTSD and opiate use is not tied together. Because here PTSD is tied with pain and pain is tied with opiate use. But PTSD and opiate use aren't tied together. Okay. So what we're going to do is we're going to go through and restructure our equation, right? And so what we're going to do is pull down anything that doesn't involve my conditional effect. And right now, I've got conditional effects of pain and I got conditional effects of PTSD. So to start out, I'm just going to pull down when I'm restructuring this, I'm going to pull down my intercept. And then I'm going to pull down opiate use because opiate use is in a conditional effect in my model, right? It's involved in an interaction, but it's serving as the moderator here. So it's not a conditional effect. People see what I'm talking about as conditional effect. If I were to restructure this and have pain as the moderator of both of these, then my restructured equation is going to look different, right? What we're trying to do is go down through, as you're doing this, think about like what I want to see is an effect of pain that changes based on opiate use. I want to see an effect of PTSD that changes based on to the level of pain or of pain. Right? So here opiate use doesn't play in, so we pull opiate use down. And then I'm going to bracket off my two conditional effects. Okay. I've got pain and I've got PTSD. So what I'm going to do first, I'm going to say, okay, I've got a conditional effect of pain. Where are my pain terms at? Okay. Pain terms, I've got 10.5 times pain. So that's going to come down. And then I've got opiate use times pain. This is sort of my interaction term here. I'm going to bring this down. Okay. I've got a pain term over here. Why don't I not bring that over here into this? Why not, Catherine?
Can you repeat that?
What's that?
Can you repeat that?
Yeah, so I'm pulling down terms that contain pain. I've got pain here and I got pain here. I'm bringing these down and factoring this out. Why don't I grab this has got pain in it? Why don't I bring that down?
Or it's tied to PSYC.
It's tied to PTSD. That's part of the conditional effect of PTSD, right? So I've got my pain term and my interaction term. Okay. Everybody look at me. Order of operations, make very, very, very sure that you're pulling down positives and negatives correctly, because if you don't, then things are going to get switched around. Okay. So notice here, I've got a negative coefficient for pain. That is a negative coefficient here, positive coefficient here, pulling this down, right? And so then you're going to do the same thing for PTSD. Here's the base effect for PTSD and then the interaction here, okay? And this is my final restructured model. Conceptually, what I can see is that whatever this coefficient is going to be for pain is going to depend on whatever value I put in for opiate use, okay? And here, the effect of PTSD on my outcome is going to be completely dependent on what value there is for pain in there, okay? So we can start to see how this goes through. Another thing, again, brush up on your algebra skills. If you've gone down through and you've got this equation here, to know whether or not you've done this correctly, go through and then just run this out to go back the other way, right? So if I go through and I take this, I'm going to have 10.04 minus 0.86 opiate use minus 10.5 pain plus 0.460 opiate use times pain minus 0.19 PTSD plus 0.17 pain times PTSD. If you just reverse your algebra, you should get back to here. This is a really, really, really valuable step, because if you've messed this up, you won't end up back here and you'll know you've made a mistake somewhere. Okay. So as you're starting to get sort of a hang of this, restructure your regression model and then sort of multiply it out and make sure that you get back to there. If you've done that, you'll know that you've done it correctly. Yeah.
And just by multiply it out, you just pick any value for the variables and.
Oh, no. I'm talking about just when you're restructuring this. If I'm going through and I'm saying, okay, so I've got, and so let's say this is the solution that I've come up. Okay, I think I refactored this, right? Well, go through and check and say, okay, well, it's 10.04 minus 0.86 opioid. And then this is just basic algebra, right? I've got 10.56, negative 10.05 times pain, right? If I multiply that out, right? And then 0.460 opiate use times pain plus right? So I've got that, and that's back up what I've got here, right? And I've got minus 0.19 PTSD, right? Plus 0.17 pain times PTSD. Okay. If I just reverse engineer that and I get back up to where I was before, this will save you a lot of headache, because As you're getting used to this, it's easy to get the stuff turned around and flopped around. Always, once you go through and get your restructured equation, just multiply it back out and just make sure that you get your original one here. Because again, if you've made a mistake, you'll get something that's not what you got up there. All right, so again, for my restructured equation, I can see that the effect of pain is now conditioned on opiate use, right? Whatever my coefficient for pain is going to be, it's going to depend on what value of opiate use I plug in there. It is by definition dependent on level of opiate use. Same thing, effective PTSD is now conditioned on pain, right? Whatever this coefficient for PTSD is, my simple slope for PTSD is entirely dependent on what value I throw in there for pain. So again, in this multiplicative model, effects of pain here and PTSD, both of these are going to be conditional effects. Now, if you don't have evidence for, you don't have evidence of an interaction effect, then the value here will change, but your model is saying it's not moving around by anything that's interpretable as sort of meaningful or things along those lines, right? Or at least we don't have evidence for it. But so numerically, in terms of absolute terms, it'll change. But if your interaction isn't interpretable, you're like, well, it's just kind of fuzz and noise with that moving around, right? But this is why when I'm going through and I'm setting up regression or sort of these models, I'll go through and center everything just to start out with. Because that way I can just say, here is, even if my interaction terms don't turn out, I can say, well, this is the effect of X on Y, holding everything else constant or controlling for it. So I don't have to pick if whether or not, let's say opiate use and pain doesn't turn out to be a significant interaction, then I don't have to choose whether or not this is for, or if I'm looking at my effective pain, it's not when I'm using opiates or not, it's just kind of controlling for those. I don't have to choose which coefficient I'm going to use for that. All right. People see how we're going through and restructuring this equation. And sort of, again, you're thinking back to 8th grade, you're like, when are we going to use algebra? Algebra is terrible. Now in doctoral class, in doctoral statistics, you're using it, and glad you have those skills. Who do people remember their middle school algebra teacher? Who was it?
Miss Cap.
Miss Cap.
So Brian,
It's almost like Miss Clap, like that's close, yeah.
She sucked.
Why did you not like Miss Gosley?
She just like gave us an insane amount of homework for 8th grade, and then like we could never get it done. And she was the type to like walk around and see that you hadn't done this problem, and then be like, go up on the board and do it, since I know you didn't do it for homework.
Oh, she sounds rad.
To me.
Do you remember yours, algebra teacher? What's that? That's not, you just made that up.
No, it's true. For 2 years.
All right, that's all this is. It's just going back through and sort of getting brushed up on this. And if you practice it, like you start to get good. But again, this is with these types of models. And this is the thing that makes me nervous about stuff like process, is like doing it sort of by hand. I can go through and double check to make sure that everything's square and I know that it's working exactly the way it's working. If I just give this to sort of a program, I don't trust myself enough not to have made a mistake and sort of messed something up, and then less of an ability to go through and see sort of things are working out the way I wanted to. So now that's not to say so Cindy and Charlotte, you're both using Stata. Stata will just go through and crank these out for you. You just go through and so you don't have to walk through the whole process. If I'm running moderation now, I just do that because I've done this for decades and I'm sort of good at it now, right? But I still make mistakes. Okay, I'll still sort of forget to do something and so I got to go back through and do things. It becomes easier for me to diagnose where I screwed my stuff up than it will be for you all sort of starting to pick things up. Just assume that you're going to make mistakes and sort of have, here are my checklists to make sure that everything is squared up and looking the way it should. Okay. So what we want to do is here we can go through and we want to go through substituting high and low values for pain to go through and look at the moderating effects of pain on the relation of PTSD and neural functioning. Okay, so I've gone through, I've restructured my equation. Now what I want to do to plot these out, I want to just start throwing in values of my moderator. And here I've got, again, because I've got centered pain, low pain, the standard deviation below is negative 0.34, high pain 1.34. All we need to do is start throwing these into our model, right? So here's my restructured regression model right here. Okay, my restructured equation, I go through, is opiate use relevant to what I'm talking about? Nope. In my model, what does controlling for opiate use? Opiate use is 0. And this is really nice. Again, another thing mathematically when we're centering things, because if I'm holding things constant at 0, things just go away. So controlling for opiate use, I'm just plugging 0 into there. Those two terms go away, right? And so I'm left with 10.04 minus 10.05 pain plus 0.17 pain minus 0.9 opiate or PTSD. What I'm going to do is I'm just going to plug in high pain values is 1.34. Anywhere there's pain, I just plug in 1.34. So here, and run this out is giving my simple slope for PTSD. Okay. So I've got my intercept here is negative 3.43 plus 0.04 PTSD. This is my simple slope of PTSD conditioned on high pain severity. So if I'm looking at holding pain constant at a standard deviation above the sample mean, what I'm saying is I would expect for every unit increase in pain, I would expect an increase in functioning of 0.04. Okay. That seems kind of weird if I say that out, sort of that with an increase in pain, I'm going to see an increase in functioning. What might be going on here, Jack? I don't know. William?
Yeah, if you're experiencing a lot of pain, PTSD doesn't have an effect on functioning, or it has a minimal effect on functioning.
Okay, probably you're right. It looks like an absolute increase. I don't know that this is a different value than 0 right now, right? So if I'm going to go through and plot this out, I'm going to get a positive line for this, but I don't know if this is actually a statistically significant change, right? So let's go through and see what's happening at low levels of pain, okay? Again, I can just start here because I've already gone through and restructured down. I'm plugging in negative 0.134 for my effect, and I get my simple slope with PTSD on low levels of pain, okay? So again, here's my intercept, and now what I'm saying is conditioned on low levels of pain for every unit increase in PTSD, I'm saying 0.42 unit decrease in functioning. People see how we went through and just by hand got our simple slopes for the effect of PTSD on functioning at high and low levels of pain here. This is something that's going to take some practice. You're going to have to keep going. But again, always when you're doing this, I want you to be thinking about like, what does this literally mean? Okay. This will help you immensely. So here we've gone through and solved, we got simple slopes in our full regression model for PTSD. Okay. Let's switch over. Let's take a look at the conditional effect of pain. Okay. What we're going to do here is substitute values corresponding to use or non-use, holding other variables constant at the mean, and to go through and get our effective pain. Okay. So for no opiate use, here's my full restructured regression model. I'm holding PTSD constant at 0, so those terms go away. Because if I take 0 times this, all of that's gone, right? So that's nice. All that leaves. If I hadn't centered my model, this starts to become a lot more complicated, right? So centering just goes through and simplifies things a great deal. So I go down here, here's my restructured equation here. And what I'm gonna do is I'm just gonna go through for no opiate use in this data set that ends up being a value being represented by a value of negative 0.5. I go through, plug that in, and I get my simple slope for the conditional effect of pain on functioning for people not using opiates. Okay. Here's what we got here. And then the same thing. If I go through and plug in values corresponding to people who are using opiates in this set, here we go. And it goes through and breaks that down there. People generally following with this. Questions? So again, want to note here that holding PTSD constant, I mean, that's going to be fine so long that it doesn't, that level of PTSD doesn't moderate opiate use times pain, right? If there is a three-way interaction, right? If levels of PTSD change the nature of that two-way interaction, then what we've got is a three-way interaction and some of my stuff's going to be off, right? We've got a specification error going on here. But as long as don't have evidence of a three-way interaction, then we're good to go, okay? A lot of times this ends up being conceptual in nature, right? Because you might think like, well, why don't I just go through and include the three-way interaction? And then anything that doesn't sort of pop up as interpretable, I'm just going to go through and remove that. You do that, and people do this. Why might a person take exception to that as an approach? You think, William?
I mean, you're just disregarding something that might be there.
Yeah, right. But it wasn't in my model. It wasn't significant, so it's not there. It means that it doesn't exist. What's wrong with that?
It's like the whole, you don't test for COVID, you won't have COVID.
Well, exactly, right? You trying to talk your way out of a high level of administrative position with this stuff, right? Because I don't find a significant effect in something, does that mean that it's not there? No, it's largely driven by sample size, right? Just because I don't find something doesn't mean that it's sort of not there or not important. It just means I might not have the power to do it, or my data might not have captured it, right? So we can run into this issue where we got some circular logic, like, well, it's not important because it's not significant. But I don't know if we use that logic, we wouldn't even have opiate use in this model to begin with, because it didn't pop up on my first regression model, right? So I just thrown it out. Does that mean it's not important? No, it just means I didn't model it correctly to actually capture the effect that it was having, right? And so you do see in some areas, so this model building, model trimming, so I go through and I run the model, if it's not significant, I go through and sort of leave it out, right? The problem is that's purely data-based, and you're relying on your data to be perfectly representative and perfectly accurate and generalizable to the population, which you should never assume, right? Sometimes you have a stronger assumption than others. This is why it starts to fall back on conceptually. Do I have a reason to expect that PTSD levels would change the nature of the interaction between opiate use and pain? Maybe, right? But if I don't have a very clear and easy solution for that, then I'm probably not going to include it in my model. Or include it in your model and just leave it alone. The problem is you're going to have a regression model that's got like 14 different predictors and sort of a bunch of interaction terms. It starts to get a little bit messy, right? So you could go through and do full factorial stuff. It's just going to contain a lot of things that you couldn't explain even if you did have them in there, and it's just going to make for a messy presentation. So again, it relies on you to know your content area and to be able to, before you go through and run the model, say, if this pops up, this is why it would pop up, this is what it would look like. If you can't do that, even if you sit and think about it, you probably would question on whether or not you need to have that interaction. Questions about any of this? Okay. So if we go through and we start to go through and test our simple slopes, okay? Here we have the conditional effect of pain on functioning for people who are using opiates and people who are not. Okay. Or excuse me, top one, here's opiates and no opiate use. So here, conditional effect of pain and functioning. This is continuous low pain, high pain. Okay. Jayla, what is going on with this plot here? I'll tell you right now, this is a trick I'm setting you up to say. Tell me what you're seeing with this. Yeah, just go ahead and tell me what you see.
I would just say it's interaction because
Okay.
you have like the high people or the low pain, higher functioning, and then you see like a crisscross where like the rate of decrease is like more to people
Okay.
with no.
Oh, I didn't fall in my trap. So smart, right? No, what will often happen when people are looking at these, and again, this is not, it's just kind of what your mind normally goes to. You don't have to raise your hand, but who here with this was like, oh, well, at low levels of pain, we're seeing higher levels of functioning here and here, and then high levels of pain, it swaps around, right? Issue is, are these real values in the universe? No, these are model predicted values. Is there anything special about where I specifically centered low pain and high pain? No, right? What we're doing with these continuous regression models, like Jayla said, we're interested in rate of change, continuous change across sort of the levels of our moderator, right? So an appropriate interpretation of this is going to be, it looks like for individuals who are not using opiates, we're seeing a stronger association of PTSD and pain relative to people who are not using opiates, or of pain and functioning relative to people who are not using opiates. Okay. The critical thing here is you're interpreting these slopes and not differences. Okay. Because these are just arbitrary points. These are model implied points. These aren't actual mean values that are observed in your data. Because this is an ANOVA, right? This is just saying my model is saying that this is my best prediction for what the rate of change looks like across across pain and functioning for people with no opiate or who are using opiates and for people who aren't. Okay. So when you're making interpretations of your simple slopes here, you need to be focusing on changes in the association and not trying to make interpretations about sort of those data points. Okay. I say this in the first paper I ever published. I jimmied some stuff up to be able to make sort of interpretations about sort of these 2 points. It started to become important so that for addressing questions, because we had a cross sort of issue right there, and people like, oh, well, it looks like at this level functioning is higher than that. And say like, no, it's not. It's actually even predicted that sort of these points are not different, so we don't need to worry about that, right? If you ever have need of doing that, come talk to me. I can go through. And it's actually just recentering your intercept and this is the 0 point. So your intercept is capturing this. And then you just look at confidence bounds and look at the overlap of those confidence bounds and things along those lines, right? So, I mean, you can do it, but you shouldn't unless you're sort of trying to address a reviewer issue. Because again, what we're focusing on is the relation, okay? So Catherine, what about sort of this? Here we're looking at the conditional effect of PTSD on functioning at high and low levels of pain. What are we seeing here?
See. Like low levels of pain. Kind of it's a stronger association. And also a little bit of a different direction.
If I'm looking at this, I'm saying that it looks like there's a stronger association of PTSD and functioning for people who are experiencing low levels of pain, where we're saying as PTSD increases, functioning decreases. Jack, what's going on down here for people at high levels of pain?
There potentially isn't a difference between low versus high.
Yeah. The line is positive, but I don't know that that's a slope, right? That looks pretty zero to me, right? Probably what's going on here is that positive slope is just like this zero, this near zero estimate just happened to kick in the positive direction as opposed to the negative direction. Conceptually, okay, so that's what's going on in the graph, right? But then again, I just don't want you to tell me what's going on in the graph. I want you to be thinking carefully about like, what does this mean, okay? Cindy, for so this top one, what is this? Does this specific interaction that we're seeing, does this make sense? Given what we might think about sort of the relation of pain and medication use and things along those lines. Yeah, tell me why this kind of makes some sense.
Well, if you were to step over meds,
What's that?
if you were to use like the meds, you would kind of like see that, like even though the pain increases, it wouldn't really
Yeah.
impact your overall function.
We're seeing that still for people who are even using medications, as pain increases, functioning decreases, but it's just less of a strong association than when we're seeing people not on pain. So we could sort of make an argument for that these pain medications are doing something. Okay. William, what's going on here? You kind of alluded to this earlier.
Yeah, so in people with high pain, you know, whether their PTSD symptoms are low or high, it doesn't seem to have much of an effect on their functioning. But those who are low on pain, the higher amount of PTSD symptoms they have, the worse their functioning is.
Right. Take note of this, particularly you clinical folks, right? Because when I was talking about this interaction of pain and PTSD on the front end, I'm like, oh, yeah, PTSD is going to have an association with functioning, but then if I layer in pain, then it's going to make it even stronger. Is that what happened? No, right? What happens if I throw a bunch of just physical pain on people? It doesn't matter what my level of PTSD is, my functioning is through the floor, right? I am just like I'm bottomed out my scale at high levels of pain, right? You often see this back, oh, well, here's sort of this thing, and then we add depression, and it's going to sort of exacerbate it. Like oftentimes it won't. It's back if I'm horribly depressed and I can't get out of bed, like the other thing doesn't matter. It's just sort of kind of icing on the cake, right? So this actual pattern is nothing like what I had predicted, but if I'm looking at it, I can come up with sort of a reasonable conceptual explanation for why we would see a pattern like this. And this starts to become really important in thinking about like, what did you see and how do you account for it? Yeah, Jayla.
I was just gonna say, like, is it a matter of like how it was measured then?
It could be, right? So it could be on this. And if you remember from the original regression stuff, this functioning measure is not really all that great. It's categorical in nature. There's a bunch of stuff wrong with it. We log transformed it when we were doing the regression stuff. So yes, 100%, right? I might have, it's possible that my measure is just not sensitive at capturing sort of really low levels of functioning, or maybe it's just people floor out, right? And so knowing these data, I think that's probably it, is people just kind of floor out. Looking at this graph, is there anything weird about this that doesn't make a ton of sense? What's going on with our Y scaling?
That's negative.
Yeah, can we have negative values by functioning? No, right? And so again, always remembering that these are model implied values, right? I hit sort of like in this one, like everything's like you're below zero, you're less than sort of like the lowest value that you can score, right? My model doesn't know that, it's just predicting in the negative and that's where it would go, right? But I can't translate to that to an actual score on my measure because like everything kind of floors out, right? Does this mean my model sucks and is no good? No, it just, one of these things you want to start to be thinking about in terms of how you're presenting things, right? In general, because again, we're not worried about the absolute value of these. We're interested in the association. And so the actual intercept of this probably doesn't matter a ton. The relations that we're seeing are sound, but if I go through and plot it like this, if you give me as a reviewer, I'm gonna look at it like, wait a minute, how does that go through it? So you gotta be thinking about this stuff. What I would probably do is I would probably just present these as standardized scales, not the raw metric. And then we sort of reduce that so like someone to like get worked up about that piece of things. But again, one of these things, when you're going through and you're evaluating stuff, you always want to like make sure you're taking a look at the details. And so, yeah, this is implausible because like these values can't exist because it floors out here, right? And this, here's where like that's totally not even in real space, but it's more about we're not looking at, it's not like we're doing mean-based analyses where you at the mean of your group is something that's not on the scale. That would be a problem, right? Here it's just looking at the relation and the model just happens to set that below where we would expect things to be. Questions about this? How are people feeling about this? Okay, here what I've done, and again, I think we got a slide here. Okay, setting these up in Excel. Okay, again, a really nice tool to be able to go through and sort of plot these out, make sure that things are working the way you want them to. What I would do here is create your 2x2 table of your outcome variables at high and low levels of your conditional variable and M, okay? And then just use the calculation thing to just type in your values, and then just substitute your high and low levels of X, okay? Going through and getting this, you got negative values, standardized solution. Here's a way to go through and adjust it. And then switch on rows and columns just so that what you want is your plot to actually display your conditional effect on the x-axis and your other things. Sometimes it'll just flop it around. If it does that, you just hit switch rows and columns and it'll flip-flop it for you. Okay. And so this is what it is. So here's a screenshot for how I set this up, right? So here I've got for my first one, I've got low pain, low PTSD, high PTSD, and then I've just sort of dropped in my regression model. Okay. Same thing, and that's for all of these. Then you just pull up your thing. It's pretty slick and easy to set up. Okay. And sort of wanting to see this when you're going through and presenting your simple slopes, just so I can go through and take a look at your values, make sure that they're correct stuff. Okay. How are we feeling about kind of the process and restructuring our these regression models? Again, it's just some basic algebra stuff, but you'll need to knock off the rust on some of those skills. So again, go through, and if you're worried about this, I gave you a pretty slick handout, if I do say so myself. So what I had to do is figure out like sort of rust back, how do I actually explain this to people to go through and like, so it's like you get a little mini algebra lesson in there. So go through, take a look at this, practice this. You want to make sure that you're able to sort of go through and do this because it's a good check. Okay. All right, let's go through, take a break, come back in 10, and we'll jump into testing these simple slopes. Okay. So what's really cool up to this point is we've gone through and we've analyzed our regression models with our interaction terms, and we've got simple slopes, we've got interpretive stuff. We've basically done everything just by hand, right? We didn't need to rely on a computer program to go through and do stuff. If you've got that regression equation, you've got everything that you need to go through and plot out your simple slopes, test things out, get your coefficients across the board, which is pretty cool, okay? And again, when I'm going through and doing this, if I have evidence of a non-zero action term, right? If I go through and I look at SPSS and I'm seeing that interaction term, it's P less than 0.05, it's significant. This by definition is giving you evidence that the effect of X on Y changes across values of your moderator, okay? So when you're going through and looking, we kind of skipped over that, but when you're looking at your output, what you want to go through and look at is the test of that interaction term. And if that interaction term is something that's interpretable, you have evidence that yes, the unique effect of X on Y is changing across levels of my moderator, okay? The issue is this does not give you evidence of whether or not you have non-zero effects of X on Y at sort of plus or minus 1 standard deviation or any other level of the moderator that you might want to set at, right? And okay, going back here, when we went through and plotted out our simple slopes for the relation of PTSD and functioning at high and low levels of pain, right? Again, we saw something that probably looks like a very clear effect of a negative effect of PTSD on functioning at low levels of pain. But then here at high levels of pain, it looks like we've got a positive relation, a positive effect of PTSD on functioning. This is saying like, as if I'm giving a literal interpretation of this line, suggesting that as levels of PTSD increase, functioning increases for people who have high pain. Does that make any conceptual sense? Not really, right? What we can't get with the model that we've run is looking at whether or not we have evidence that this is something that's different than zero, or what is the true magnitude of this effect, things along those lines, right? We can get everything from just hand calculations, but we're kind of stuck when we hit this. So what we can do though is we can harness the power of SPSS and algebra to start bending it to our will to be able to go through and get actual tests for this stuff, okay? And what we're going to do, and again, this is if we're using a standard approach of looking at the effects of conditional effects at a standard deviation above and below. All we need to do is just go through and make a couple modifications to our multiplicative model here, okay? So again, we're wanting to look at the impact of pain severity on the relation between PTSD and role functioning, okay? So what we're going to do is we're going to separate this out a little bit, okay? So I'm testing this. What I want to do is test the simple slopes for this piece over here, okay? So what I'm going to do in SPSS or in Stata is I'm going to go through and I'm going to take my moderating variable and I'm going to create two new variables in the set that correspond to high and low levels of my moderator, okay? I'm going to create new variables. I'm going to create a variable called high pain, and high pain is going to be equal to my pain variable minus a standard deviation. Okay, I know standard deviation of pain is 1.34. So to create a variable, my high pain variable, I'm going to take variables, sort of values of pain in my set, and I'm going to subtract 1.34. Then I'm going to create another variable in my set. It's going to be called low pain. And low pain is going to be my pain value minus a negative standard deviation, which is going to give me plus 1.34. Okay. This is kind of counterintuitive, right? Because in order to get my variable for high pain, I'm subtracting a standard deviation. In order to get low pain, I'm adding a standard deviation, which seems not the way I would expect it to be. I would think for low pain, I would subtract a standard deviation. For high pain, I would add a standard deviation, right? But let's take a look at on our graph what's happening, okay? So here we've got centered pain, okay? Mean is 0, okay? Standard deviation is 2.3. And we've got, we'll say, Jack, your case number 23, you're right at 0 right here, Okay. Let's say I go through and I recalculate, rescale this for my high pain variable. And what I'm going to do is I'm going to subtract 1.34 for every value in my set. If I do that, if I subtract 1.34 from every value in my set, what ends up happening is my new mean is now negative 2.3. Okay. Because I took all the values, which was my mean was 0. I subtract 2.3 from all my values. My new mean is negative 2.3. Jayla, where does 0 now exist in my distribution? Here.
It's like on the right side, but I actually like I don't
Yeah.
understand the standard deviation being 2.3.
Oh, that's just what the standard deviation of the distribution was. Okay, yeah. So here is, we're just saying that the standard deviation of pain is 2.3. Okay. So here, if I go through and I take all for my center variable and I subtract the standard deviation, my new mean for my high pain value is negative 0.23, but my 0 value, which everything is being estimated, exists at a standard deviation above. Okay. Same thing if I go through and I, for my low pain variable, if I add one I'm sorry, that should be 2.3, not 1.34. That's probably what people, someone have sort of computer up. William, can you sort of tell me to change this? This should be 2.3, not 1.34. But if I go through and I do this, right, if I go through and I subtract or add a value of 2.3 to everything here, what it does is it goes through and it shifts everything up. So now 0 corresponds to low pain. And this is where my model is estimating at. Okay. So just remember when you're doing this, it's a flip of what you would normally think, right? To get your high moderator value, you're subtracting a standard deviation. To get your low moderator, you're adding a standard deviation. Okay. So what you're going to do is after you've gone through and you've rescaled your moderator to correspond to high and low values, right? What you're going to do now is you're going to create 2 new interaction terms corresponding to your condition values of your moderator. So you're going to have a new variable that's going to be high pain by PTSD. It's just going to be your high pain variable multiplied by your PTSD value. Low pain by PTSD, it's just going to be your new variable that you created for low pain and multiply that by PTSD. Okay. So in your data set, you're going to have 2 new variables that correspond to high and low levels of your moderator. And then you're going to have 2 new interaction terms that correspond to the high and low levels. Then what you're going to do is you're just going to create a new regression model. And all you're going to do is you're going to substitute whatever terms in that you're actually interested in looking at here. So for looking at your conditional effect of PTSD on functioning at low levels of pain, you're just going to go through, here's your intercept. You're going to swap out your centered pain variable for low pain, plus opiate use, plus PTSD, plus your interaction here for opiate use by low pain, and an interaction of low pain by PTSD. For this, because we've got a couple things in here, we would also go through and create interaction terms for low pain and opiate use, so everything lines up here. Okay. And when you go through and you run this model, this coefficient for PTSD is going to give you the unique effect of PTSD on functioning at low levels of pain. All we're doing is we're just in the model, we're just shifting around that 0 point. And same thing for looking at the conditional effect of PTSD on functioning at high levels of pain. We're just going to take anything where pain was and we're going to swap out low pain or swap out pain for your high pain variable that you created here. So here we got intercept, high pain, opiate use, PTSD, opiate use times high pain pain times PTSD. And now we're getting sort of the conditional effect here for the unique effect of PTSD on functioning at high levels of pain. in these models that you're running, the only thing that you're interested in terms of interpreting is just this. Everything else is just a means to an end to get where you're at. Now, there are things that you should be looking at in this model to make sure that it squares and make sure that everything's the same, right? But the only thing that you're interested in these models is this. Do you need to report the R squareds or everything that's going on in the model? Nope. The only thing you're interested in is these coefficients, okay? So you don't need to go through and read, like trudge through S and BFB, like, because it doesn't matter. All you're doing is, the only reason you're doing this is to look at sort of your p values for these, because everything else you already got out of your condition, your hand calculations, your model restructuring. There's nothing unique or new that you'll get out of this except for p values and effect sizes for this. People see what we did with this? Yeah, yeah.
Why is the opioid, like in this?
Because with our model, remember that we had opiate use was involved in interaction with pain. And so just because if we just used our original opiate use by pain, we'd have this interaction being scaled at a different level of pain than everything else in the model, and it would have sort of thrown things off. So we're just going through and we're sort of making sure that we got that accounted for in the model. Okay. So in short, what we're doing when you're testing simple slopes is you're just going to create new variables that correspond to high and low levels of your moderator. And then you're just going to look at your regression equations that you've already written out. In any place where you see that variable, you just need to make sure that that term corresponds to low levels or high levels, just to go through and make sure everything's tied up with that. So, wanting to go through and take a look at the effect of centering on your additive models. We already talked about this, right? So if we go through in my additive model where we have pain, opiate use, and PTSD, and centered pain, centered opiate use, and centered PTSD, if we go through and look at this, R squareds are the same. Our coefficients are all the same. The only thing that changes my intercept, and we talked about why that is, right? But if I go through and I take a look at my multiplicative models, now things start to change, okay? Now for my centered solution, my uncentered solution, my overall model doesn't change. My R squared is the same because all you're doing is just playing around where the 0 point is. So your overall R squared shouldn't change at all. If it does, something's gone wrong, okay? But what you'll see is you'll see your coefficients start to change, okay? Here in my uncentered solution, my constant represents the unique or sort of the expected value of my outcome when pain and PTSD are held constant at 0, meaning like an actual value of 0, and for people who are not using opiates. Okay. Over in my centered solution, though, my constant is corresponding to the expected value of functioning when pain and PTSD are held constant at the mean, controlling for opiate use. Here in my uncentered solution, this is the expected effect or the unique effect of pain on functioning for people who aren't using opiates, and when PTSD score is literally 0, as in like there's no PTSD, right? But over here, we're seeing the expected value of, or the expected effect of pain on functioning, controlling for opiate use, PTSD held constant at the mean. But because we've got these interactions, sort of this is the conditional effect, right? Here in the uncentered solution, this is the conditional effect of pain for people without PTSD who aren't using opiates. Here, this is the conditional effect of pain for people at average levels of PTSD controlling for opiate use. And because we have evidence down here of an interaction of PTSD and pain, that means that that slope's going to change depending on what these other values are, okay? So what you'll see, and when I'm talking about first order effects or conditional effects, that's all this stuff here, okay? And you'll see because all of these terms are involved implicated in an interaction, you'll see that all of these terms are different. Okay, they all change across the centered and the uncentered solution. Well, what's going on down here when we're looking at your interaction terms? Charlotte, are we seeing differences there?
No.
No, they're not, right? Because centering will go through and change things except for your highest order interaction. In this model, we've got two-way interactions. Your two-way interactions are not going to change. They're always going to be the same. Okay. Now, if we were to layer on three-way interaction, say we have PTSD, opiate, and pain, your three-way interaction would be the same, and your lower order interactions, those are going to start to change around. Okay. This starts to become critical in determining whether or not your model is doing the thing that it's supposed to be doing. Okay. So again, if we go through and we take a look in our model here, we have evidence for an interaction of PTSD and pain, and we're kind of right on the edge for opiate use and pain. We're going to go through and interpret that. We'll call it good enough. Okay. Do I, Catherine, need to start making a big deal about interpreting these coefficients here? No, because those are going to change around depending on sort of what the levels of the moderator is, right? So if I'm going through and interpreting this model, I'm probably going to go through and maybe talk about my overall model, kind of looking at how that is. And then what I'm going to do is I'm going to just jump right in the interaction. I have an interaction, right? Everything down here is really not worth talking about right now because it's all going to change depending on sort of my level of whatever, right? These are all in this model conditional effects because they're going to change depending on sort of what the other value is. So we're seeing here my p-values, okay? And again, you notice that your p-values don't change for your interaction terms, but your p-values for your conditional effects do, because we're talking about these are different simple slopes, right? This is the simple slope of pain on functioning at average levels of PTSD holding opiate use constant, right? This is the simple slope of opiate use on functioning at average levels of PTSD and pain. This is the conditional effect of PTSD on functioning, controlling for opiate use at average levels of pain. Okay. These also represent conditional effects. These are just different conditional effects because zero means different things in this model versus that. People kind of see what's happening with this. Okay. Other thing too, taking a look at here's where we start to, and historically, if you're looking at sort of Aiken and West and going through some of those readings, one thing that we'll see in our centered versus our uncentered solutions, if you look at your collinearity indices right here, wild differences across your centered and your uncentered models. Okay. Here with your centered models, these are yikes, right? Because you're like looking at values here that should be like above 0.1 or something like that. You've got wild collinearity here. These VIFs are through the roof, right? This is where when you look at old school like Aiken and West type of thing, where they're talking about collinearity in your data set, right? If we go through and take a look at your centered solutions, it goes through and eliminates that collinearity, okay? And so nothing going on here that would cause concern. If you were just to see a general model like this that didn't have interaction terms in it, you should be very, very concerned about all that, right? Because basically you're taking variable A, variable B, and then the product of those two and plug it in the same model. These are highly interdependent on one another. When you go through and center, it sort of disrupts that in the covariance matrix. Okay. Now, in your standard OLS regression, even though it looks bad, in this context, it doesn't do anything. It doesn't change anything. It doesn't mess with your standard errors. So it's not a huge deal. And this is why Hayes will go through on an anti-centering rant. I don't think that Hayes really cares that much about centering. It's just if you get like people like lose their mind because you didn't center stuff in an OLS regression, he's just saying it's not actually a big deal. Okay. Now, if I were to take these variables, want to run them in an SEM or sort of use like a maximum likelihood estimator or something like that, this will destroy your model. Like it just won't estimate. It'll all fall apart, right? So something to keep in mind. But just know when you hear about centering goes through and addresses collinearity, this is what it's talking about. Okay. You will also note that I've gone through and crossed out your standardized coefficients for your multiplicative model. That's because the standardized coefficients that you'll get in SPSS or Stater or things along those lines aren't proper. They're not the right standardized coefficients. We got to do something a little bit different to get those, which is a pain in the neck, but it's easy enough to address. Questions about what we're seeing here? Okay. Always look at this, compare your sort of knowing sort of, well, this, you don't need to run uncentered and centered variables, or solutions, but just knowing this and understanding why you're seeing changes starts to become important, sort of getting a handle on these models. Okay. Same thing, if we're going through taking a look at your correlations, here are your first order effects or your sort of base variables. That doesn't change across centered and uncentered, but like you'll start to see wild differences in terms of your correlations with interaction terms. Okay. This one is an incredibly important slide. Okay. Here is my full model. Okay. This is the model that we went through with our centered variables. So we have centered pain, centered opiate use, centered PTSD, and then the interaction of centered opiate use and pain, the interaction of centered pain and centered PTSD. Okay. What you'll see, and so here again, we've got sort of our model here. What you'll see here is my coefficient table for the simple slope of PTSD on functioning at low pain and the simple slope of PTSD on functioning at high pain. Okay. You'll see that as I go through here for low pain, I've swapped out pain for low pain. Opiate use is the same, PTSD is the same, but now I've got low pain by PTSD and low pain by opiate use, swapping these out. Okay. Over here for high pain, swapped out pain for high pain, opiate use is the same, PTSD is the same. Now I have high pain and PTSD and high pain and opiate use. So two separate models. Notice here that again, my interaction term or the coefficients for my interactions don't change at all, right? If you're seeing changes in your interaction terms, you know something has gone wrong. You need to go back through and figure out where you've messed something up, okay? But all your first order effects, well, not all your first order effects, most of your first order effects are changing. Your intercept is changing relative to this, okay? Because again, we're recentering, so where your expected value is. Your conditional effect of opiate use is changing, right? Because we're changing where opiate use, or because opiate use is involved in this interaction of pain and PTSD. So high and low pain is changing that conditional effect of opiate use. And then you're seeing a change in your conditional effect of PTSD across all these because we're changing where pain is and PTSD is included in interaction. What you're not going to see is your coefficient for pain is going to be the same across all of these. Okay, we've recentered pain, but we didn't recenter anything else. In this model, we're still looking at the average levels of PTSD and controlling for opiate use. So this did not change across any of these. Okay. So again, it's this pattern. If you've done this right, you need to recognize what's going to change and what doesn't, right? Here, your lower order effects and the coefficient for your moderator aren't going to change, but everything else should change. So again, this is kind of your check to see, like, is this model performing the way it should? And if it doesn't, that's sort of a flag that something needs to be, you need to go through and check on something. Questions about this? Okay. Other thing too, Charlotte, can you go back through and pull up in when we hand factored out that equation? What did we have? Yes, I'd go up. Full model. Here's simple slopes for, oh, that's opiate use here. simple slope for PTSD, when we went through and just hand calculated this out, what was your coefficient for your conditional effect for PTSD at high levels of pain?
It's just 0.04.
0.04. Right, what was your conditional effect for PTSD at low levels of pain?
Negative.
Negative 0.4, right? Again, you should see, again, as a double check on this, when you go through and you hand calculate things out, you get some rounding error because this is taking things to 15 decimals and in your hand calculations, you're probably not, right? But you've already got these coefficients. They should be the same. If you got something that's wildly different, again, suggests that something's gone wrong somewhere, okay? The only thing that you're getting out of these simple slope equations, you've already got this, right? The only thing that you're getting is this, my p-values across these, and then your standardized coefficients and effect size, things along those lines. Okay. So again, please, in your write-ups, don't march through a full interpretation like this is a brand new model. And like this is a brand new model, it is, but the only thing that you're doing is you're just changing around. The only thing that you're interested in here is your conditional effect and testing that and getting a p-value for that and relevant associations. Okay. All right. Questions? Okay, let's go through and I will give you links to walking through this in SPSS and data and sort of like how to go through and sort of like where the pull down menus and things are at. Let you do that on your own. But what I want to do is I want to walk through just kind of the handout here and talk through kind of what we're doing in SPSS. So and as by extension you do so the same version in SATA for how you go through and actually sort of get this stuff. Okay, so here we've got the same model that we were looking at before. Okay. And again, here's PTSD, pain, opiate use, role functioning. What we're going to do is we're first going to go through, get our descriptives, right? And it's going to give us our sort of descriptives table right here. And based on this, we're going to create our centered pain, centered opiate use, and centered PTSD variables. Okay. Have you created variables in SPSS up to this point with? Okay, so familiar with this. So here we're just going to go to compute. Centered pain is pain minus the mean. Okay. Make sure when you're centering, you're subtracting the mean, right? When we're doing high and low levels of your moderator, you're subtracting standard deviations. Here, make sure for your centered variables, you're centering so that this is mean centered stuff. So we've got centered pain is pain minus the mean here, opiate use minus the mean here, PTSD minus the mean here. Okay, so we go through, calculate that, and then what we're going to do is we're going to run descriptives of our centered variables. The means for these should be 0. If they're not 0, something's gone wrong. Okay, here for opiate use, it's not exactly 0. It's something small. It's just because this is not exactly 0.5. We just kind of rounded it up, but that's good enough. That's fine. So always do this to make sure that you've gone through and centered it appropriately. Okay. So once we've got our centered variables, we are going to go through and we'll skip this. This is just looking at the difference between our centered and our non-centered models. So you don't need to worry about that. Okay. But what we're going to do then in SPSS is once you've gone through and you got your centered variables, you're going to go through and you're going to create interaction terms. Okay, same thing, you'll do this in Stata. Okay, you can't just in the sort of pull down say in Stata you can just say, hey, should I add sort of multiply these together and Stata will do it on its own for you. SPSS weirdly won't. It will do it for a logistic regression, but like you actually have to build variable in SPSS to go through and do it. And in Stata, like this is where state a shortcut comes into play. I still want you for this to go through and build your interaction terms, but you're gonna create a variable called pain by PTSD, another one opiate by PTSD. It's just gonna be the product of these two variables. So in SPSS and in SATA, you're gonna have two new columns well, you're gonna have three new columns for your center variables, and then you have a couple new columns for your interaction terms, okay? This starts to become really, really important. You're gonna have a lot of new variables. Make sure that you're labeling these intuitively in ways that make sense to you, labeling things so you know where stuff's at. And then what we're gonna do is we're gonna rerun this regression model. We're gonna regress role functioning onto pain, centered opiate use, centered PTSD, and the interaction of your centered variables that you created here. Okay. And here's the table that we're getting. So again, this is just what we've already seen. We've got evidence of, I mean, if we're looking at this, we're saying we're getting a conditional effect of pain at average levels of PTSD, controlling for opiate use. At average levels of pain and average levels of PTSD, we're not seeing a conditional effect of opiate use, right? Here at average levels of pain, controlling for opiate use, we have a conditional effect of PTSD on functioning. But here, really what we want to do with this first model, you're just going to jump right down to your interaction terms, see if we have evidence of an interaction. And here, for PTSD and pain, we very much do. For opiate use and pain, and so that borderline piece of things, right? I'm not gonna be like, no, nothing to see here. This is not different than 0.05 or 0.049, right? You might have to get in a fight with a reviewer about this, but this is certainly something we're moving forward and discuss. Okay. And then here are our coefficients. So when you're going through and interpreting these models, again, I would talk about your overall model, your R squared, things along those lines, but don't march through, because these are conditional effects. These are all going to change depending on what your simple slopes are going to be. Okay. If sort of thinking about this from an applied standpoint, we've got here's PTSD, here's functioning, right? We go through and we look at this is low pain and for high pain and low pain. That's kind of what that plot looked like, right? Yeah. Where does the simple slope of PTSD and functioning lie at average levels of pain? Sort of based on this model. What do you think, Catherine?
Like in between.
Yeah, it just bisects it, right? This is the thing, when people will go through, and oftentimes they'll go through and like on their simple slopes plots, have simple slopes at high and low levels and then average levels of your moderator. You can do that if you want, but I mean, your simple slope at average levels, by definition, is just gonna bisect those two in the middle, right? Because this is another thing, understanding what's going on with these models. What you're modeling here is still a linear effect. It's saying that the relation, the moderating effect, you're testing the assumption that your moderator has a linear impact on changes in slopes. It's saying that as your moderator changes, it's having a linear effect here. Okay. That may or may not be the case. There may be something, so you start to hit thresholds, right? Like it's here, it's here, it's here, it's here, until I tip over a thing, and then it's going to go through and jump up. That's not what's being tested here, right? What your model is doing is it's assuming that that conditional effect is changing in a smooth linear fashion across levels of your moderator, right? So here, this line right here, this is the simple slope or the simple slope of PTSD on functioning sort of at average levels right here. You see how that's kind of fitting together. Okay. So we go through, get our model, and we see we have evidence for interaction or multiplicative effects of PTSD and opiate use. So feeling pretty good about that. Okay. So what we want to do then is we're going to go through and run our simple slopes. Okay. So here's the simple slope of PTSD and functioning at high levels of high and low levels of pain. Right. We just went through that. Here's me just restructuring my equation here. And then what we're going to do now is this is the other thing too. Anytime we get an interaction, very first thing you need to be doing when you get an interaction is going through and plotting this out, right? Don't try and sort of like, also with your interaction term here, you all are great. And we've been talking about sort of interpreting this these coefficients literally as sort of per unit increase in this, we're seeing a corresponding change in this. With your interaction, don't worry about that. You can do it. Like there is a, but don't worry about it, right? So this is, I mean, it's literally talking about the expected change in your simple slope per unit change and sort of that, but like it's a headache. Don't worry about that. All you're doing is for these interaction terms, you're just looking at the test. Please don't try and give me a literal interpretation of these. Okay. So you go through, you see, you have interactions. Anytime you get an interaction, first thing we do is go through and plot these, go through, plot your simple slopes, go through, do this. One, it's going to be a check, and two, it's going to give you already a sense for what's happening in what you're looking at in terms of what the nature of this interaction is going to be. And then when you actually get into testing it, if the results that you're getting and your coefficients don't map onto what you're looking at here, then you know something's gone sideways. Okay. Repeated theme is like always have a way to know when something has gone sideways with these types of analyses. Okay. So what we're going to do now in SPSS is we're going to go through and we're going to say, okay, I want to go through and request my descriptives for pain, opiate use, and PTSD. Okay. And then what I'm going to do is I'm going to start calculating my high and low levels of things. So here I'm going to create, so my pain is my moderator for this first test, right? So I want to create a variable that corresponds to high and low levels of pain. So here, my low pain variable is going to be centered pain plus a standard deviation. High pain is going to be centered pain minus a standard deviation, okay? And now I'm going to go through and I'm going to create new interaction terms of anything that includes pain. So here I've got low pain by PTSD is low pain by centered PTSD, high pain by PTSD, high pain by centered PTSD. And then I've got these opiate interactions. Jayla, we talked about this. It wasn't something we're necessarily interested in this specific effect, but we still got to make sure our model's consistent. And so I'm going to create interaction terms of low pain and opiate use, high pain and opiate use. Okay. And then I'm going to go down through and I'm going to run my two regression models here. We've got our first regression where we're looking at the conditional effect of PTSD at low levels of pain. Here's our outcome. We got low pain, opiate use, PTSD, low pain by PTSD, low pain by opiate use. What we're getting here. Separate model, high pain, conditional effect of PTSD on high pain, centered opiate use, PTSD, high pain and PTSD, high pain and opiate use. And just going through. It's kind of like a puzzle. You're just like swapping things out, sort of making sure that things are consistent, right? And again, here in these models, the only thing that we're interested in is this conditional effect of PTSD at high and low level. Everything else in the model doesn't matter outside of just as a check to make sure that you're doing things right. So again, doing this in the actual test is you're going to be creating a lot of different variables. You want to make sure that you're labeling that in ways that are sort of making sense to you intuitively. Okay. So then we're going to go through, take a look at our pain functioning for people with and without medications. Okay. Now here we're going to go through, we've restructured our equation. We've got our simple slopes here. But we're going to do something a little bit different with our data set, okay? Because remember, here we're looking at the conditional effect of pain on functioning for people who are using opiates and who are not using opiates. Are we doing a standard deviation above or below of opiate use? No, that doesn't make any sense. We've got two variables, we've got 0, 1 variables that are very clearly indicating people using opiates or not, okay? So what I need to do though, is I've already got my original opiate use variable in my model where 0 is no use and 1 is use. What I need to do now is I need to go through and I need to create opiate R, where 0 corresponds to use and 1 corresponds to no use. So again, I'm gonna create a new variable in an SPSS. What I would do is I would just sort by opiate use and create a new variable that says opiate R. And then for people where there's zeros, just enter ones, or there are ones, just enter zeros, just to flop that around, okay? So now that I've got two indicator variables for opiate use, one where 0 corresponds to no use and another one where 0 corresponds to use. Now what I'm gonna do is I'm gonna go through and I'm gonna compute my interaction terms. So I've got an interaction for no opiate and pain, just opiate times centered pain, because that's my original variable. And then I have yes, opiate use by pain is opiate R times pain. Now I've got sort of interaction terms that correspond to use of opiates and non-use of opiates. So dichotomous variables are actually kind of slick because you just kind of flip those around. You don't have to worry about recentering things. All we're doing with this is we're just changing what 0 means. So always, always, always know what 0 means in these models. Okay. And then if I do that, then I'm just going to run a couple of new models here to test this piece, right? So I've got in my first model, this is looking at testing the conditional effect of pain on functioning for people who are not using opiates. So I've got centered pain, opiate use, centered PTSD, PTSD by pain, or pain by PTSD, and no opiate use by pain. And here's my model here. Okay. Here, I've got looking at conditional effect of pain for people who are using opiate medications. Same thing. I've just got pain, my reverse coded opiate use, PTSD, pain by PTSD, and yes, opiate by PTSD. Swap those around. You'll notice that both of these models are different than my base model. Why? What did I do with opiate use in my base model? Yeah, Jack.
It was like 0.5 and.
Yeah, it was centered, right? And so this is why typically for my base model, when I'm doing this, my base model, because I don't know whether or not we're gonna get interaction effects or not with both my dichotomous indicators. I'll usually go through and center those dichotomous indicators, and that way in my base model, I can just say, these are the effects controlling for that. But then when I get into my simple slopes, now I just went through and using my original opiate use, because 0 there is no use and 1 is use, creating interaction terms, and then sort of flop that around, create an interaction term for that, right? That way, even if, let's say I don't have an interaction, then I'm not then I can say like this is splitting the difference between these things. All right, but again, we'll see here that my highest order interaction terms are not changing. Opiate use, which is my moderator. The sign flips on this, but the actual magnitude of that relation doesn't change. And also notice here, Catherine, are we seeing a difference in my coefficient for PTSD? No, why not? PTSD isn't tied to opiate use in this, right? So PTSD here, we're not seeing a change in my coefficient for PTSD because PTSD isn't involved in interaction. So it doesn't matter what opiate use is at because PTSD isn't sort of modeled as being dependent on that in any way. And so we're saying opiate use doesn't change, PTSD doesn't change, your higher order interactions don't change, but we're seeing differences for your conditional effect of pain, which is the only reason we're going through and doing this. And if you go through and you take a look at your conditional effects here and here, they're the same values that we got when we hand calculated it. Everything's something to 0 on this, so we know that we're in a good spot. you will go through into like the actual sort of video stepping through the SPSS sort of process, and also Stata kind of go through and show you kind of, I'll talk through what we're doing and why and things along those lines. But this should sort of hopefully give you kind of an overview of what this process looks like. Basically, you're just going through and you're calculating new variables in your data set to go through and populate your model. Just got to make sure that you know what's going on where. The other thing that I will say when you're going through and putting together your syntax files, just make sure you're labeling things really well so that you know what's going on, because that's a phenomenal reference to be able to go back through and be like, okay, what did I do? What's the steps? What's the process? Kind of like you're building your own little study guide for down the road when you have to do this for papers or posters and theses and stuff like that. You will be happy you took the time to sort of go through and put good records there. All right, questions on any of this? All right. Okay. So remember that when I was going through and we had this table, I'd gone through and crossed these sort of standardized coefficients out, okay? The issue is that SPSS, neither SPSS nor Stata, probably not R or anything else too, is actually calculating these correctly in this model, okay? Remember that for your standardized coefficients, right? Your standardized coefficients are representing per standard deviation unit increase in my predictor. Here's the expected standard deviation unit change in my outcome, okay? What SPSS is doing to calculate these standardized coefficients, all it's doing is in the background is it's going through and it's taking z-scores of your outcome, z-scores of all your predictors, and taking those z-scores and regressing the z-scores of your outcome on the z-scores of your predictors. And then from that model, taking your unstandardized coefficients for your z-score solution, and then just dropping those in for your standardized coefficients there, okay? This is easy enough to do. You can do this. I'll have you do it, I think. Where you go through it, if you just run a regression model, and then you take z-scores of all your variables and run the z-score model, your coefficients in your z-score model will be equal to the standardized coefficients in your regular normal model, okay? So here's the thing, like, do we, when we're centering variables, do we center our y variable? No, we don't need to center our y variable, but if you get a standardized solution, everything gets standardized, everything is z-scores, okay? Problem is when we run into this with our interaction terms, what happens is that SPSS is going to go through. So you've got in this model, you've got a coefficient for, you got centered pain, you got centered opiate use, you got centered PTSD, and then you have the interaction term, right? The product of opiate use and pain and the product of pain and PTSD as two separate variables in your data set. What SPSS is going to do to get you these variables is it's just going to do the same thing it always does. Is it's just going to take the z-score of everything and regress the z-score of your outcome on the z-score of all your predictors, right? The problem is that when SPSS does this, I can't unfactor these, right? I can't restructure this equation. I can't sort of get these back into their component parts, because what SPSS is it took the z-score of that product coefficient. And the z-score, your product coefficient isn't the same thing as the product of your z-score for opiate use and your z-score for pain, right? And the z-score of that interaction term you calculated for pain and PTSD isn't the same number as the z-score for pain and the z-score for PTSD. You can't sort of work backwards, like it fell into the black hole. You can't get this information back out. And that's problematic because you can't factor this out, so that these are not proper solutions. They don't actually mean anything. So if you were to just go through in your and just report your standardized coefficients for your interaction terms based on the model that you get from SPSS, like the default model, these just aren't going to be correct, right? They're not going to be terribly off, and probably no one's going to call you on it. But we're trying to do like real science, right? And sort of we're just wanting things to be appropriate, right? The solution is not too hard, right? All you need to do is, in order to go through and get this, is what you would do is in your model, Catherine, you're gonna go through and you take, so you've got your outcome and then all your predictors. All you're gonna do, and you probably have this already, because if you're doing things appropriately, you've already went through and created z-scores for everything. All you're gonna do is you're just gonna create z-score interactions. We're gonna take the z-score of opiate use and the z-score of pain, those z-scores that you created, and then you're just gonna multiply those and create a standardized interaction. Same thing, the z-score for pain, the z-score for PTSD, you're gonna multiply those, and then you get an interaction for that. And then what you're gonna do is you're just gonna run a separate model where you've just got the z-score for your outcome regressed on the z-score for opiate use, z-score for your interactions. And the unstandardized coefficients in that is going to be is going to be your beta weights for your two interaction terms here. Okay. So it's a little bit of a process to go through and just get proper values for these two coefficients. But if we're doing things right, it's a good thing to do. Also, if you go through and just flag that in your analytic session, in your analytic approach section, and just like footnote that and say interaction terms were calculated based on blah, 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 and cite Aiken and West, make you look like a boss, like you know what you're doing, then people will be scared to question you. This person knows, this person's for real, they know what they're up to, so I'm not gonna sort of hassle you about things, right? It's also just the right thing to do. So do people see how we're going through and getting this? Because what we would want to do with this standardized solution would be able to break these coefficients out, their components. And what SPSS does is it takes the interaction terms that you created with your centered variables and z-scores of those. We can't separate those out. So easy enough thing to do, just takes a couple of extra steps. Questions about this, or what we've got going on, or why we're doing this? Click. All right. How are we feeling about standard moderation? Kind of getting the general concept. Cindy, we're gonna get so good at moderation. It's like you're just gonna
Go crazy.
yeah, it's just like moderating everything, that thesis, right? Okay. So what we've gone through up to this point is our standard sort of simple slopes approach. Okay. And this is pretty standard psychological research. And what we'll do is we'll go through and take our moderator and we'll look at a standard deviation above and below, and it's just go through and run the simple slopes that we're all familiar with. Okay. People have criticized this approach though, because what we're essentially doing is we're basing our whole interpretation on evaluating this conditional effect of X and Y for semi-arbitrary values of M. Like they're not completely arbitrary, they correspond to a standard deviation. That's a statistical value that kind of makes some sense. But it might not really sort of make sort of a ton of sort of sense in terms of like actual like practical or clinical utility or anything along those lines, right? A standard deviation is maybe interesting, but why not a standard deviation and a half? Or why not at sort of low levels or high levels based on a cut point on a scale or something along those lines, right? Also, if I go through and I start to increase the value of, so let's say I've got this, right? These are my simple slopes. As I start to increase the value of my moderator to 2 standard deviations, 3 standard deviations, what happens to my simple slopes? They start getting farther and farther apart. I can start to mess with stuff and make things look bigger than they are, sort of based on what are the values I'm setting in my moderator. Okay. What I also am not able to go through and do is start to sort of look at cool things. And so maybe if I'm looking at sort of this, right? Maybe I'm interested in saying like, at what level of pain is PTSD stop being associated with my outcome, right? I don't know. Here it's very clearly not. Here it very clearly is. But like, at what point do we get that shift where it no longer changes, right? I guess I could just like randomly try and figure stuff out, but there's just a lot of information that I'm not able to go through and tell based on this, what people will, in derogatory terms, refer to as a pick a point approach. Okay. So again, the problem with this is there are an infinite number of simple slopes graphs that could be produced from an interaction. One standard deviation above and below may or may not correspond to anything interesting. And two, what we can't do with this is start to look at boundary conditions for at what point does the relation between X and Y flip? At what point does it stop becoming interpretable? Things along these lines. Okay. So we've got a different approach to the way to look at this, which is sort of at this point my very much preferred approach to doing this because it's just really, really interesting and a nice way to go through and take a look at things. It's called the Johnson-Niemann procedure. Has anybody seen this or heard of this or worked with this before? A little bit, William. Where was you?
Heard of it. I've
Heard of it?
them.
Okay. What this is doing is instead of going through and plotting simple slopes, right? And simple slopes are nice. Like I still doing moderation will still present simple slopes because people understand simple slopes, people like simple slopes. You just limited the types of interpretations that you can pull from these, okay? With the Johnson-Niemann, what we're doing, instead of plotting simple slopes for 2 or 3 values, what we're doing here is we're creating a plot looking at the conditional effect of X on Y and corresponding confidence bounds over a range of moderators, okay? So the plot here is going to look a little bit different. Okay. So what I'm going to do, I'm sure SPSS will do this somehow, but Stata will do it quickly. Is what I'm going to do is I'm going to go through and I'm going to tell Stata in this example that what I want you to do is I want you to go through and give me the simple slope of X on Y across levels of moderator, starting at this value, increasing at levels of this, across this range, okay? And so what I get here is a test of the simple slope of my conditional effect on my outcome at whatever the low bound of my moderator is, and then at like a 0.05 increase, and another 0.05 increase, and another 0.05 increase, and another 0.05, all the way down through the full range of the scale, whatever I tell it to do. Okay. And so again, in this table here, I've got the conditional effects of X on Y for values of my moderator ranging from 0 to 9 at intervals of 0.05. Okay. So this is giving me hundreds and hundreds and hundreds of individual simple slopes. Okay. And if I were to go through and do this and take a look at sort of this is taking a former student's thesis, looking at the unique effect of PTSD on social functioning at differing levels of empathy. Okay. If we go through and we take a look at my simple slopes, this is kind of what this looks like. Here's the expected effect of PTSD on functioning at low levels of empathy and the unique effect of PTSD and social functioning at high levels of empathy. Okay. So at low levels of empathy, we're seeing a negative relation as PTSD increases, social functioning goes down for individuals scoring standard deviation below the mean of empathy in this sample. And for people scoring a standard deviation above the mean, we're seeing it's like not really an association there. PTSD doesn't appear to be related to social functioning at high levels. So this is a fine graph. This is a good graph. This tells a story and it's okay. And so here is my coefficient at low levels of empathy, high levels of empathy. Here's my coefficients, confidence bounds, p-values, S and BFB. So as we might report this for our simple slopes graph. Here's what we get for our Johnson-Niemann plot for empathy, okay? What we're seeing here on the x-axis, this is empathy. Empathy is our moderator here, okay? Starting at low levels, going to high levels is a 0 to 9 scale, okay? And what we're seeing, here's empathy, but now on the y-axis here, this is your conditional effect, okay? This is the coefficient for PTSD across the range of your moderator, okay? And you see, because again, so these linear regression models are plotting a linear, a conditional effect across levels of your moderator. We're saying as empathy levels decrease, the conditional effect of PTSD on social functioning becomes less and less negative. Okay. And you'll see confidence bounds around my conditional effects. Okay. And then here you'll see this red line for zero. Charlotte, what does that red line for zero? If this is the conditional effect of PTSD on social functioning, what does that red line represent?
I'm totally sure.
And so what's the number there?
It's just 0.
0, right? And so if the conditional effect of PTSD on social functioning is 0, what does that mean? There's none.
Oh, it's literally just.
This is just your null line, okay?
Okay.
And so if I go through and I take a look at this, Catherine, at what point does the conditional effect of PTSD and social functioning disappear?
Is that the highest way?
Yeah, kind of up here, right? What I can see is it looks like what I've got here is the relation of PTSD and social functioning at a standard deviation below and a standard deviation above. Here, what I've got is the continuous conditional effect of PTSD on social functioning across the real range of my moderator. And what I can start to do is I can say PTSD holds a negative association with social functioning over empathy levels until we get to, oh, here's your low level and here's your high level. Okay, these are my pick a point levels. So here, standard deviation below is 3, standard deviation above is 8. Okay, so if I look at a standard deviation below empathy, this is my conditional effect of PTSD is negative 1.63. Here's my confidence bounds for that. So I have evidence for a negative association of PTSD and social functioning at this level. Okay. But Jayla, as soon as I get here at high levels of empathy, which is this right here, do I have evidence of a conditional effect at that point? I'm looking at my confidence bounds here.
Are you saying because the red line is like within the confidence bound, so there's not?
There's not, right? This confidence bound contains 0, right? So what I'm getting here is, so here is my simple slope at low levels. Here's my simple slope at high levels. What I get with this graph is I can start to go through and start to test, well, where does empathy, at what level of empathy does PTSD stop demonstrating an association with functioning, at least based on my model? And this model would say, well, at about 6.75, that confidence bound crosses that null value. And so what I can say with this, I can say that increasing PTSD is associated with reductions of empathy from values of 0 to about 6.75. Once we get above that, all of a sudden, like with increasing levels of empathy, PTSD no longer has an association with social functioning, right? Which is kind of a cool thing to go through and be able to start talking about, like, what's the boundary? At what point does this association disappear at the level of my moderator, right? I could also go through and, what is this? This is 6.15. No, I can't remember what that was. Here's 6. Oh. Yeah, I can't remember if this was something that made sense to me at one point. But 6.75 is not a real value you can score on this scale. So, but here's a level of 6. This is kind of what that is, right? And so you can go through and start doing sort of interesting things. Here's the mean, right? Where things are at, right? And so what you can do is you can start playing around with sort of different values along this scale and start saying sort of where things at. Now, all of this is saying like we're having a decrease or an increasing negative value of that coefficient that's this is an increasing value of that negative coefficient, which means it's getting closer and closer to zero, right? But what we can start doing with this is we can start making sort of much more interesting interpretations relative to my pick a point approach here. Okay. This makes some sense to people. I'm not going to have you do a Johnson-Neiman plot because haven't sort of figured out how to make SPSS do it. I'm sure there are macros and things along those lines. And actually process will do this for you, I think. I haven't played around with it, but I'm sure it will sort of go through and jump this out. But again, if you're working with moderation analysis and you want to get a little bit more sophisticated in how you represent those, what I do is I don't trust people to go through and like have an intuitive interpretation of this. So I'll usually do both at this point. Yeah, a really slick way to go through and present some of this. So you go through and do that instead of. All right, questions? Okay, cool. Last thing we're going to talk about here in terms of building these moderation analyses is talk about how we start going through and doing this if we've got multicotomous indicators, okay? What we've done is we've sort of worked with some categorical variables, and remember, so if I've got a dichotomous variable in my model, that coefficient is just telling me the difference across those two groups, expected difference across those two groups once we account for other things in the model, okay? But sometimes I might have an occasion to have something, Jay, let's say you go through and you're want to look at like experimental condition. You've got condition 1, condition 2, condition 3, and you want to include this as a moderator in your model. Like, how do we go through and start doing that, right? Good news is it's pretty easy. We can just go through and start dummy coding things and start to get sort of everything we would need from these models. Okay. Dummy codes, if I go through and I have a categorical variable, lots of different ways to go through and code. Dummy code is one of the simplest ones. Depending on what you're trying to do, there are different ways to go through and code things. Dummy codes are nice because they're just 0-1 variables, okay? What I'm going to do, let's say I've got a categorical variable with 3 levels. If I'm going to go through and dummy code, I'm going to end up with the number of levels of my categorical variable minus 1. That's the number of dummy codes I'm going to have in my model, okay? So for a 3-level variable, I have 2 dummy codes, and that's going to capture all levels. If I had 4, it's going to be 3, so on and so forth, okay? So let's say I'm interested in the unique association of type of degree and GPA with starting salary, okay? And I want to know whether or not a degree moderates that relation between GPA and starting salary. I'm an education major looking at higher education stuff. Is GPA related to starting salary? And does that start to change across different types of degrees? Okay. So in my model here, and this is just kind of, here's my participant number, here's what degree they have, GPA and salary, okay? And my degree variable here, I've got 1 is liberal arts, 2 engineering, 3 business, okay? This is a nominal variable. There's no sort of 1, 2, 3 is better than sort of anything else. They're just different, okay? And what I'm going to do is I'm going to go through and I'm going to dummy code this where I want liberal arts is my reference group. So because I've got 3 levels to my variable, I'm going to end up with 2 dummy codes. My first dummy coding is for engineering. 1 is engineering, 0 is everything else. Second dummy code for business. 1 is business, 0 is everything else. Okay. Jayla, do I need a dummy code for liberal arts to run this model? Nope. Because if I've got if I grab Cindy, and Cindy has a 0 on the code for engineering and a 0 on the code for business, what is Cindy's major? Liberal arts, okay. What happens if I go through and I create a dummy code for liberal arts and drop that into the model? The world collapses on itself because we've got a sort of singularity in there, right? Because by definition, if I know a dummy code for business, and I know the dummy code for engineering, the dummy code for liberal arts is already determined and it's, your model just won't run. It'll give you a big error message. Okay. So what I can do is I can go through and run a regression model that will start to give me a comparison in salary across my different degrees here. Okay. Let's say I go through and I regress salary onto my dummy for engineering and my dummy for business. Okay. And this is the model that I get. Okay. Catherine, what does my intercept represent here?
Like the, what is it, salary if you're liberal arts.
Perfect. Right? If I drop 0 into this, 0 into this, who am I talking about? Folks who have a liberal arts degree. This is my starting salary for individuals with liberal arts, right? William, what does this coefficient for engineering represent?
Slope for engineering.
For engineering, and is engineering continuous? Do I really have a slope for this?
Slope. It's the expected money an engineer major
Relative to
relative to liberal arts major.
right. In my model, this is the average difference in starting salary between liberal arts folks and engineering, right? And you can see basically with this, if someone's a 1 here and a 0 here, then we're starting as liberal arts is like our baseline, and then we just increase by $7,000, and that's where your engineers are. Same thing for business. This is just the difference in my model implied difference, or actually in this model, it's the actual observed difference. Average difference between liberal arts and business degree holders sort of within this model. Again, starting at 2,100, we're just adding $3,000 to this, and now you're up to business. Okay. So again, what we've got is the intercept mean salary for liberal arts. V1 is the difference in mean salary for engineering and liberal arts. Same thing here. So we don't really have a slope. Right? These are just differences in sort of levels across this. Jack, what did I just run here in our regression environment?
Just like a standard regression, like
That's a standard regression. What we're thinking if we were to tackle this last semester, how would we have maybe looked at this? If I was interested in differences in mean salary across 3 different majors.
ANOVA.
Yeah, I just ran a one-way ANOVA in my regression environment. That's what this is, right? If I were to go through and look at the F for my R squared in this model, it's going to be identical to the F I would get in my ANOVA table, right? And arguably the regression is the better way to do this because I've already gone through and separated a contrast out. The p-value for my dummy engineering dummy is just telling me, do I have evidence of a non-zero difference across engineering and liberal arts? P-value for this tell me if I have a non-zero difference across the expected value for the average value for liberal arts versus business, right? We've actually just run an omnibus test and a couple of contrasts with this regression model, okay? ANOVA is just a special case of regression. Arguably, this would be a slicker way to go through and do it because it gives you more as opposed to having to go through and do some stuff. People kind of see how this is being set up here. All right. And again, my overall regression, my R squared is to add testing the hypotheses that salary doesn't differ across my degree type. But if I wanted to go through and take a look at the relation of GPA and salary, then this is something that would be difficult to do in a one-way ANOVA because I've got GPA as a continuous variable, right? I can do this super easy in a regression model. All I'm doing now is I'm going through and I'm setting up my model. So I've got a dummy for engineering, dummy for business, and then I just include standard GPA as a predictor in this model, okay? And here's what I go through and I get in terms of my regression output, okay? And so what I get here is I get my intercept is my expected value for liberal arts holding GPA constant at 0, okay? Now, here's a good example for why it makes sense to go through and mean center things. Because if I don't center things, does anybody get a degree with GPA equals 0? No, it's not a sort of, maybe, I don't know. But it's not a real number. It's sort of anything that's sort of interpretable, right? And in this situation with these categorical variables, the intercept does start to become interesting because it's telling me my expected value for one of my groups, right? So centering this, we're saying at an average GPA, we're saying this is the expected salary for liberal arts folks at average GPA. My coefficient for engineering, this is my difference in mean salary in engineering and liberal arts. If I control for GA or GPA, same thing for business. And then my coefficient here is changing the expected salary per unit change in GPA for liberal arts. And that is technically a correct interpretation of that model. Does it really matter if I'm talking about liberal arts? No, right? Because the conditional effect or the unique effect of GPA on starting salary in this additive model has to be the same for everybody because there's no interaction terms to be built in on that. What we can then do is we can start to generate multiplicative effects here. And so what we can start to do if we start adding in our interaction terms, it's starting to give us estimates of the differences in the relation of GPA and starting salary if I'm looking at different degrees. Anybody here have engineers in their family? Anybody have friends who are engineers? Okay. Engineers sort of need to get all A's to sort of make money at the end of the day. Nope, not really, right? C's to get degrees, right? It's getting out you on the other side, right? It's possible versus if you're a liberal arts major, so if you're worried about that straight A's thing, you know, going across. And so it's possible that the relation between GPA and starting salary differs depending on what degree you finish with, okay? And that's what we're looking at here, right? Here's our model where we've got dummy for engineering, dummy for business, center GPA, and then my interaction of engineering by GPA and business by GPA. This is the model that I get from this. Okay. We'll leave it at that. All right. Yes.
Sorry, this is on the last slide, actually.
Yeah.
So there's the GPA negative on positive below average and above that?
Yep. This is just a standard deviation below and a standard deviation above.
Oh.
Yep. Yep. Just use those. Other questions? All right. Well.